In this video, I want to talk about how to find zeros of a polynomial function that's written in factored form. So first, I want to talk about what are zeros. So zeros can be called zeros, roots, or x-intercepts. And basically, these are all the places where the function is equal to 0. So here, and here, and here, and here in the case of this polynomial. Now this polynomial is not the function that's written here. This is just an example of where we're finding our zeros, roots, or x-intercepts. These are really important points because it's where the graph is equal to 0. It's also where it changes from positive to negative. So here the y values are all positive and then they change to negative. They change back to positive, they change back to negative, and they change back to positive. So these are those changing points, the points where the y value changes from positive to negative. It's also the points where the graph crosses the x-axis, which is why they're called x-intercepts. And so we can find these by setting the function value equal to 0. So 0 is equal to x minus 3 squared times 2x plus 5 times x squared minus 16. And the good news is that when it's already factored, we don't have to work very hard to find the zeros. So we just need to look at each factor and see where each factor is equal to 0. So the first factor is x minus 3 squared. Now my question is, does the squared do anything or change anything in this case? Well, the answer is yes, it changes something for the polynomial. It means it's a repeated root. But the answer is no, that it doesn't change anything in terms of the zeros. So we don't have to worry about this making anything different because it's squared. We just need to set x minus 3 equal to 0, which would give us x equals 3. So one root is x equals 3, or one of the zeros is x equals 3. Now let's set 2x plus 5 equal to 0. And if you can do this in your head, that's fine too, but I'm going to write it out just this time. So 2x equals negative 5, so x equals negative 5 halves. Okay, that's our second root. For the third one, we need to set x squared minus 16 equal to 0. Now, when I look at this, I actually see that it can be factored further. So I can factor this into x plus 4 times x minus 4, and that equals 0. So then x can be equal to negative 4 or x equals positive 4. Or you could solve it by moving the 16 over and square rooting both sides, but then remember that it needs to be plus or minus the square root of 16, which would be plus or minus 4. So in this case, these are the 4 zeros. X equals 3, x equals negative 5 halves, x equals negative 4, and x equals 4. Those are the 4 zeros of this particular polynomial function. And when it's written in factored form, all we have to do is set each part equal to 0 to find the zeros.